Your walls are made of wood. Your floor joists are wood. Your roof trusses are wood. And somewhere inside those walls right now, moisture is sitting, insects are testing their luck. And every degree of seasonal temperature change is making those boards shift just a little bit. Not enough for you to notice today. But give it 10 years, and you're going to start wondering why your doors don't close right anymore, why there's a soft spot in that one section of floor, and why the corner of your garage is pulling away from the wall. That's not bad luck. That's lumber doing what lumber does. And the frustrating part is that better options have existed for decades, and most builders are still reaching for the same 2x4s they were using 50 years ago. So, let's talk about why that is, what those better options actually look like, and what you as a homeowner need to know before you build, buy, or renovate. Hit subscribe before we begin, because this is one of those videos that's going to follow you into every contractor conversation you have from here on out. I'm Jerry Davis, and I've spent years in construction, renovation, and building consulting. I've framed houses. I've torn open walls. I've walked through homes that were barely 20 years old and looked like they were ready for demolition. And almost every single time, the root cause of the damage, the rot, the structural drift, the pest damage, the insulation failures, it came back to one thing: wood framing. Now, before anyone in the comments comes at me, I'm not saying wood is evil. I'm saying we've had better tools on the table for a long time, and the industry has been slow to use them. By the end of this video, you're going to understand why that is, what the real alternatives are, and how to have an honest conversation with a builder or contractor without getting brushed off. Let's start with the most basic problem that nobody really talks about when you're buying a new construction home. Lumber moves. It expands in humidity, it contracts in dry weather, it warps when it dries out unevenly, and it does all of this after your drywall is already hung and your paint is already on. That cracking you see along the corners of your ceilings and around your door frames in a newer home, that's not a settling issue in the way most builders describe it. That's dimensional lumber doing exactly what it was always going to do. You bought a home framed with material that has a biological need to change shape, and nobody told you that at closing. Here's what no one tells you. When a builder orders lumber for a job site, a significant portion of those boards are going to be slightly warped, crowned, or twisted straight out of the delivery truck. Good framers call the worst ones and work around it. But on a production build where speed is the priority, you're getting whatever gets nailed up, and once it's in the wall, it stays there. That slightly bowed stud doesn't become your problem for another 5 or 6 years, but it does become your problem. So let's talk about what the alternatives actually are, because this is where it gets interesting. The first one is engineered lumber. And honestly, this one should be standard by now. I'm talking about LVL beams, laminated veneer lumber, I-joists, LSL, the whole family of products that takes wood fiber and bonds it together under pressure and heat into something that is dramatically more stable, more predictable, and stronger than a standard dimensional stud or joist. An LVL beam doesn't warp, it doesn't crown, it doesn't twist over time. It's engineered to carry a load consistently, and it does that job better than a solid piece of sawn lumber almost every time. Most builders already use LVL for headers above doors and windows, and they use I-joists for floor systems in a lot of builds. But the framing walls? Still 2x4s and 2x6s almost everywhere. The cost difference is real. I won't pretend it isn't. But when you factor in callbacks, warranty repairs, and the long-term structural drift in a conventionally framed home, the math starts to shift. Now let's talk about steel framing, because this one gets dismissed way too fast in residential construction. Light gauge steel studs are standard in commercial construction. Go look at the inside of any retail space, office building, or hotel being built right now. They're using steel stud framing because it's dimensionally stable, it doesn't rot, it doesn't feed termites, and it doesn't shrink. But in residential, builders will tell you it's too expensive, too hard to work with, too cold in winter. And some of that is true in a straight comparison. Steel does conduct temperature, which means your insulation strategy has to be different. But this one drives me nuts, because the pest resistance alone should be a bigger conversation in certain parts of the country. If you live in the Southeast, in Florida, Texas, the Gulf Coast states, and you're building or buying a wood-framed home, you are feeding a problem that termites have been solving for millions of years. Steel framing removes that entire category of risk, not just reduces it, removes it. And yet the default is still wood, because that's what the crews know and that's what the supply chain is set up for. Here's a pro tip. If you're building in a high humidity climate or a termite-heavy region, and your builder hasn't brought up the framing material conversation, you need to bring it up. Ask them why they're using dimensional lumber. Make them give you a real answer. If they say it's cheaper, ask them for a cost comparison on steel stud or a hybrid system. A good builder will have that conversation with you. A builder who just wants to move on to the next thing is not the builder you want. Now, I want to spend some real time on ICF construction, because this is the one that makes the most sense for the most homeowners, and almost nobody knows what it is. ICF stands for Insulated Concrete Forms. The way it works is this. You build your walls using interlocking foam blocks, pour concrete into the center of those blocks, and what you end up with is a concrete wall with continuous foam insulation on both sides. No thermal bridging. No studs to rot or warp. No gaps in the insulation from rushed installation. The concrete core gives you extraordinary structural strength, which is why ICF is used in storm shelters, safe rooms, and homes built in hurricane and tornado zones. But here's the thing. It also gives you dramatically better energy performance than a wood-framed wall. We're talking R values in the range of R20 to R30 for a wall assembly, compared to the R13 to R15 you're getting from fiberglass bad insulation crammed between 2x6 studs. And that energy performance is continuous. It doesn't degrade the way bat insulation does when it gets compressed, gets wet, or gets disturbed by an electrician or a plumber who had to cut through it. I've walked through ICF homes, and the first thing people always notice is the quiet. The concrete mass absorbs sound in a way that wood framing just doesn't. And the temperature inside feels more even, less drafty, more like the house is actually holding its conditioned air instead of leaking it out through every stud cavity and electrical penetration. The cost premium is real, typically 10 to 20% more than conventional framing on the wall system. But when you run the energy math over 20 or 30 years, and especially when you account for insurance discounts in storm-prone areas, the numbers start to look very different. Don't get me wrong. ICF construction has its limitations. It requires contractors who know what they're doing. You can't just hand the job to a framing crew that's never worked with it. And finish work on the inside requires a slightly different approach. But the idea that it's some exotic niche product is just not accurate anymore. There are ICF homes in every state. There are contractors who specialize in it in most major markets. It's available, it's just not the default, because the default is always whatever is most familiar to the most builders. Let's talk about SIPs, structural insulated panels. This is another one that deserves way more attention. A SIP is a sandwich panel, a foam core bonded between two layers of oriented strand board. You can frame an entire house out of SIPs in a fraction of the time it takes to stick frame it, and you end up with a wall system that is airtight, well-insulated, and structurally rigid. The air sealing on a SIP home is dramatically better than conventional framing. And air sealing is where most of your energy dollars are actually leaking out. Every penetration in a stick-framed wall, every electrical box, every gap between a stud and a window frame, that's air moving in and out and dragging your heating and cooling bill with it. SIP construction addresses that almost by default because the panel itself is the insulation and the structure in one continuous piece. This is where people mess up when they hear about SIPs for the first time. They focus on the material cost and stop listening. Yes, the panels cost more upfront than dimensional lumber, but you save it back on labor, on insulation installation time, on the air sealing detail work that has to happen on a stick-framed house to get anywhere close to the same performance. The total installed cost is often much closer to conventional framing than the raw material price suggests. And here's the thing that really matters for resale and long-term value. A high-performance building envelope holds its value. As energy costs go up, as buyers get more sophisticated about HERS ratings and blower door test results, as building codes continue to tighten their energy requirements, the house that was built with a superior wall system in 2025 is going to be a much easier sell in 2035 than the house that barely met code with 2x6 framing and craft-faced bats. Now let's talk about why builders don't change, because this is the honest part of the conversation. It's not entirely their fault. The residential construction industry runs on thin margins, tight timelines, and subcontractor relationships that have been in place for years. When a builder calls up his framing crew, that crew knows how to frame with lumber. They're fast, they're efficient, they've done it 1,000 times. The moment you switch to ICF or SIPs or light gauge steel, you need a crew that has specific experience with that system, and that crew might not be available next week when you need to start. The supply chain for conventional lumber is everywhere. Your local building supply house has it. You can get it in 2 days. Some of these alternative products have longer lead times, fewer local suppliers, and require more advanced planning. That's a real operational challenge for builders who are juggling multiple projects. I understand it, but understanding it doesn't mean homeowners should just accept it. If you're building a custom home and you have the time to plan, there is absolutely no reason you can't have a serious conversation about an alternative wall system. The barrier is familiarity, not feasibility. And I want to address the argument that wood is sustainable, because this one comes up a lot. Yes, wood is renewable. Responsibly harvested timber is a legitimate environmental argument. I'm not disputing that. But the sustainability argument gets complicated fast when you factor in how often wood-framed homes need major repairs, how much energy they lose over their lifetime due to poor thermal performance, and how quickly moisture damage can turn a wood-framed structure into a demolition project. A concrete or steel home that lasts 100 years with minimal maintenance and minimal energy consumption has a sustainability argument too. The conversation is more nuanced than the lumber industry marketing would have you believe. Look, I get it. Most of you watching this are not about to build a custom home from scratch. You're renovating a kitchen, adding a room, replacing a roof. But here's why this matters to you right now. When your contractor opens up a wall for a bathroom remodel and you see that the framing is rotted, that's this conversation. When you're getting a quote to add a second story and the structural engineer says your existing framing needs to be reinforced, that's this conversation. When your crawl space moisture problem keeps coming back no matter how many times you treat it, and the root cause is wood floor joists sitting in a humid environment, that's still this conversation. Knowing what the alternatives are gives you better questions. Better questions get you better outcomes. If you're doing any kind of major structural work in your home right now, ask your contractor whether any part of the rebuild could use engineered lumber instead of dimensional. Ask about a steel beam instead of a built-up wood beam over that large opening. Ask about replacing rotted sill plates with pressure-treated or composite materials instead of standard lumber. These are not crazy questions. They're the questions a knowledgeable homeowner asks, and a contractor who respects you will answer them directly. Tell me in the comments which one of these materials you'd actually consider using, or which one you've already seen in a home. I'm especially curious who's actually been inside an ICF home, because once you feel how those walls perform, it's hard to unsee it. A good builder isn't the one who always uses the cheapest material or the most familiar method. A good builder is the one who matches the right material to the right situation and gives you honest information about why. Lumber is not going away. For a lot of applications, it's still the right call. But the idea that it's always the right call is something the industry needs to keep questioning. And now you know enough to question it too. Hit like, subscribe, and share this one with anyone who's about to break ground or start a major renovation. I'll catch you in the next one.